The purpose of this video is supplementary to paragraph 3.9 and 3.10, and to show you in a little bit more detail how the formulas for a growing annuity and for the perpetuities were derived from your geometric series. So remember that a geometric series is given by the terms a, ar, ar squared, ar cubed, and so forth, and the nth term is given by ar to the n minus 1. So if we are interested in the sum of the first n terms, then that sum is given by the expression a, 1 minus r to the n over 1 minus r. So what I have here on this slide is I have the expression for the present value for a growing annuity. And from this you can recognize your A and your R. So your A is given by that term, and R is given by that term. Sorry, it's actually, your R is actually given by 1 plus G over 1 plus I. Okay, so now I can substitute my A and my R, I can substitute it into this formula here to get the present value for a growing annuity. Okay, so my present value is then A times 1 minus R to the n, and my R is 1 plus G over 1 plus I over 1 minus R. Okay, and I can now rewrite it like this. Okay, now some of these terms will cancel out. So the 1 and this 1 will cancel out, and then the 1 plus I and this 1 plus I will cancel out, and that will then simplify to what we have here at the bottom of my slide, and that is then the present value of a growing annuity. Okay, and then on this slide we are looking at perpetuities. If we are interested in the sum of an infinite geometric series, so there's no specific endpoint, then the sum of an infinite geometric series is given by A over 1 minus R. So in paragraph 3.10, the expression for the present value of a perpetuity was given by this expression here. So again, we can recognize our A, the first term, and our R is given by 1 over 1 plus I. And now we can substitute it into the formula. So the present value will be A, and then we divide it by 1 minus R. So my R is 1 over 1 plus I. Okay, and then we can do some of the terms will again cancel out. So the 1, this 1 and 1 will cancel out, and this 1 plus I and the 1 plus I will cancel out, and in the end what we have is payment over I, my interest rate. So that was for an ordinary perpetuity. And then on this slide we have the growing perpetuity. So my A is there, and my R is 1 plus G over 1 plus I. And now to get the present value, I substitute it into the formula for the sum of an infinite geometric series. My A is this, and I divide it by 1 minus R, so it's 1 minus R. Okay, and again we can cancel out. So the 1 and the 1 will cancel out. The 1 plus I and this 1 plus I will cancel out. And then we end up with payment over I minus G. Okay, and important that my I minus G must be greater than 0 for this sum to converge. So that also means that the interest rate must exceed the growth rate of the payments.